All right. A boat can be rowed at 8 km per hour in still water. Then question A, how much time is required to row 1.5 km downstream in a river, okay, in a river moving 3 km per hour relative to the shore? Now, let's say we have a river moving in this direction. This is the river, and of course, this is the shore. The shore is similar to the ground when we are talking about a car moving on the ground. So the shore is a common frame of reference. Okay, now let's say the river moves in this direction, in the positive x direction, and then a boat can be towed 8 km per hour in still water. So this is the velocity, 8 km per hour is the velocity of the boat that it can withstand whenever it's in a still water. That means that velocity is the velocity of the boat relative to water. So let's say, okay, do we know the direction of the, okay, we do not yet know. Now the question says, but we know that the velocity of the boat relative to the water is 8 km per hour, okay, as given. Now question A says how much time is required to row 1.5 km downstream. Now downstream means along to, so that the boat goes along with the water. So that means we tend to have something of this nature. Tend to have the boat moving along with the water, and it has to be a distance of 1.5 kilometer. That is downstream, that is moving the same direction with the water. Okay, now so this is the velocity of the boat relative to the water. They are moving in the same direction, and that's supposed to be 8 as given. Now the velocity of the water has also been given as 3 km per hour. So that's velocity of the water. And of course, I already explained that if you have velocity of water, it's the same as velocity of water relative to the shore or the river bank, as the case may be. The shore or the river bank are, as the question may specify, are just common frame of reference around a river or a water. So we can suppose that a car is moving probably at p meter per seconds. This p meter per seconds is the relative velocity of the car to the ground or to the earth. So okay, so we have the velocity, relative velocity of the water to the shore given as 3 km per hour. Now how much time is required? We know the distance and we have the velocities. Then how much time will be required but for the boat? So we need to find the velocity of the boat relative to the shore. If we have found this velocity, then we'll be able to find the time, since velocity is distance upon the time or displacement upon time. So we can say that the time is distance upon the velocity, but the velocity has to be the velocity of the boat to the seashore. You know, that the relative velocity of the boat to the shore is the same thing as the is the same thing as the velocity of the boat. So we can, the distance is 1.5, then let's find the velocity of the boat to the shore. The velocity of the boat to the shore, as you can see that this is one dimensional, this is relative motion in one dimension. So we can just go ahead with that formula. If you have not watched my video where I talk about relative motion in one dimension, it will be wise if you do so. So we can have, in that video I explained this formula. So we'll have relative velocity of the boat to the shore equal to relative velocity of the boat to the water, then the water to the shore. Now I think we already have all of this in the formula. We already have this to be 8. So this is 8, and then this is just 3. So eventually we'll have 11 meter per second. No, kilometer. We have been working with kilometer. Okay, so we can have kilometer per hour. It's okay, so that's the velocity. So we can say the distance is 1.5 kilometer upon 11 kilometer per hour. So if you do this correctly, so if you do this, you should have 0.1 to 0.136 hours. So you can convert it to seconds or minutes if you want to. But since we have been working with hour, I'm pleased to leave it that way. Okay. So the next question says, how much time is required for the return trip? That is for the return trip, that is for the boat to move in the opposite direction. In this case, the velocity of the boat relative to the water will be in the negative direction, that is -8. As a result, we'll have something of this nature. The velocity of the boat to the shore, this is for the return trip now, which is supposed to be equal to the relative velocity of the boat to the water plus relative velocity of the water to the shore. It will now be equal to -8 plus 5, which is plus 3, which is equal to -5 kilometer per hour. The negative sign shows where the resultant displacement will be added to the direction of the resultant velocity. As a result, the time will be equal to the distance, which is the same thing as 1.5 kilometer upon 5 kilometer. I do not need to make use of the negative sign here because this is time. Time is a scalar quantity. It has nothing to do with the direction. Okay, so 1.5 divided by 5, that will be equal to 0.3 hours. Okay, now let's solve question C. Question C says, in what direction was the boat aimed at to row straight across the river? That is, in what direction are we going to place the boat if we want the boat to row straight ahead? Now let's say this is the river. This is the river. If I want the boat to row straight across the river, I won't place the boat in this direction. I won't place the boat in this manner. I won't place the boat in this manner. Oh, sorry, I want a straight line. I won't place the boat in this manner. If I place the boat in this manner, if the movement of the river will affect it, the river moves along this direction. Now, the movement of the river will affect it, and as a result, the person on the shore will see it moving in this manner. So it will eventually not move straight up across the river. So this is one side of the river and this is the other side of the river. So in order to head straight across the river, I will need to bend it towards this manner. If I bend it towards this manner, then whenever the movement of the wind of the river comes, it will affect it, and as a result, it will eventually bend towards this manner. So I will have a straight row across the river. So this will be the velocity of the water relative to the shore, of course. and then placing it is the velocity of the boat relative to the water. So the what I will have eventually across the river is the velocity of the boat relative to the shore. So eventually I have a right angle triangle. Now the velocity of this has already been given in the question as 3 kilometer per hour, and then velocity of the boat relative to the water has already been given as 8. So we are here to find this. Okay, I think that's what we want to find. In what direction? No, the direction is what we want to find. So this is what we need, VBS. So what direction is VBS? This is the direction. So let's say that is angle theta. If that is angle theta, that means this side is the opposite. That's VWS, and then the longest side is the hypotenuse. That's VBW. Then if I have the opposite and I have the hypotenuse, that means I can make use of sine. Since sine theta is equal to opposite upon the hypotenuse. According to SOHCAHTOA, you should always know that SOHCAHTOA. Now the sine theta is equal to opposite, which is 3 upon 8. It implies that angle theta is equal to the arc sine of 3 upon 8. The arc sine of 3 upon 8 is 22 degrees. Oh, sorry, this is supposed to be, is not supposed to be so. It's not supposed to be so. Because what we are actually looking for is this. The velocity of the boat relative to the water. The question says, in what direction was the boat aimed at? So in order to row straight across the river, for the boat to row straight across the river, it has to be placed in this manner, the way we bent it. So that is the direction we are looking for, not this eventual direction, not this. So we can just, the arrow has to be towards the side. So theta remains 22 degrees irrespective of the direction of the arrow. Now, since this is what we are looking for, we can simply say that it is 22 degrees. It is actually coming from the north. The arrow is coming from the north, so we can say of north. Where does it head to? It heads to the west. So that is 22 degrees west of north. Okay, question D says, suppose the river is 0.8 kilometer wide. Okay, let's assume the river is 0.8 kilometer wide. Okay, the river is 0.8 kilometer wide. Then what is the velocity of the boat with respect to the earth? The velocity of the boat with respect to the earth is the same as the velocity of a boat relative to the shore. The shore is just an English word. Okay, you can check that up in the dictionary. So the velocity of the boat relative to the shore is the same as the velocity of the boat relative to the earth. So in order to find that, we can say that the velocity of the boat relative to the shore, okay, since this is a right angle triangle, we can go ahead with the Pythagorean formula, which is hypotenuse squared, then the other part, the sum of the square of the other parts. Okay, so we can make VB as the subject of the formula, so that's VBW squared minus VWS squared is equal to VBS squared. So it implies that this is the root of VBW squared minus VWS squared. VBW. Then we can have something of this nature. VBS is the the VBW squared, that's 64 minus 9. So if we do that, if you do that correctly, then you should have something of this nature: square root of 55, and then the square root of 55 is 7.4 kilometer per hour. Now, to find the time, the question says how much time is required to get to the opposite side of the shore. Now, time is distance over velocity or speed, but I need you to note that, okay, out of these three velocities, which one will be required to move to the other side of the shore? This vertical velocity will be required. We cannot use VWS to move to the other side of the shore. VWS is moving downstream, so it is the one that is straight up that will help us to move across to the other part of the river. So we can say the distance, which is 0.8 kilometer, upon the velocity, which is 7.4 kilometer per hour. So if you do this correctly, you should arrive at, that should be about 0. Let's solve the next problem. E says, suppose instead the boat is aimed straight. That means we need, what the question says is that suppose that instead the boat is aimed straight. That means instead of bending it in order that it will eventually be straight up, if we had set it straight like this, and then when the wind comes over, it affects it, and then it eventually comes in this direction. Now suppose instead the boat is aimed straight across the river. So if the boat is aimed straight out, this will be the velocity of the boat relative to the water. This is the eventual velocity, which is the velocity of the boat to the shore, and then this will be the velocity of the water to the shore. Then suppose instead the boat is aimed straight across the river, how much time is required to get across, and how far downstream? That means instead of using, in the other example, in the former, in question D, we made use of VBS as the velocity, where I said T is distance upon V. In this case, we are not going to, I explained that the reason why we used VBS in that question was because it is the straight up velocity. Now, the straight up velocity here is VBW, so we need to make use of VBW. And then the distance remains the same, that's 0.8 kilometer. And then VBW is 8. So if you do that correctly, you should have 0.1 hour as well. Okay. So that's 0.1 hour. Now, how much time is required to get, and then how far downstream is the boat when it reaches the opposite shore? How far downstream is the boat? So we need to find downstream. I told you is along the horizontal component. So we need to, how far downstream, that's the distance, which is velocity times time. And the velocity in this case will be this velocity, the horizontal velocity, that's WS. So, and we have it as, I think that's supposed to be 3 multiplied by 0.1. The velocity of water to the shore has already been given, that's 3 kilometers. So if you do this correctly, you should have 0.3 kilometer. So it's as simple as that. A remote controlled model airplane is flying due east in still air. The airplane travels with a speed of 22.6 meters per second relative to the air. A wind suddenly begins to blow from north towards the south with a speed of 8.7 meters per second. Find the velocity of the airplane as seen by the controller who is standing on the ground. Let's say this is the airplane moving due east. Okay, so that is the velocity of the plane relative to the air moving due east. Okay, the airplane travels with a speed of this relative to the air. So VPA has already been given as 22.6. Then a wind suddenly begins to blow from north towards the south. So from the north towards the south, the wind is somewhat coming towards this manner. It's coming towards this manner. So we can just pick one to represent the wind. So we can say the wind moves in this manner. Since this speed is given as the speed of the wind or the air, we can say that the relative velocity of the air or the wind to the ground is given as 8.7. You know, it is the ground because another frame of reference is not associated with it. So we can just go ahead. Since then, find the velocity of the airplane as seen by the controller who is standing on the ground. If from this point to this point is the relative velocity of the air to the ground, then the ground should be somewhere here and the controller should be somewhere here on the ground. Okay, we're standing on the ground. Now if you were the one standing here, the and there is an airplane flying towards the east, a wind is probably affecting it towards this manner. That means the controller will see it in this direction. The controller will see it in this direction. The wind will affect it, and as a result the controller will see it in this manner. So this is the velocity of the plane relative to the ground, that is towards the observer, towards the controller. So we can go ahead with Pythagorean formula, since this actually forms a right angle triangle where VPG is the hypotenuse. So we can say that 22.6 squared plus 8.7 squared, and that's the square root of. So that's actually equal to 24.216, which is in meter per second. So we made use of the Pythagorean formula since we have a right angle triangle.